And you're live.
And we're live.
Wow, we're here.
Yay.
What are we doing?
I have no idea.
Yeah, we know what we're doing. We're going to do this hangout.
Yes, that's true. Hi, I'm Sophie Kravitz from Hackaday, and this is...
I'm Lamore and Lady Ada here at the Adafruit factory.
And we are doing a hangout tonight about Raspberry Pi projects. So we're going to start first with Arceus.
Arceus. Oh, and everybody else, please mute your mic and just wait till we call on you so that it's nice and quiet.
You have an hour, so you got time.
Yeah, you got lots of time.
Good to know.
All right.
Yeah. Okay, Arceus.
Hi there. Hi.
Hey.
Can you hear me?
Yes.
Oh, wonderful. So it's kind of cold here, but I am just waiting for my tea to boil. But yeah, meanwhile, I can tell about my project. Can I start now?
Yeah, go for it.
Yeah.
We're listening.
Okay. The problem was that you want to start a project with a Raspberry Pi, or you want to just maybe tinker with it, or you have some educational ideas. And the problem is, as for me, the problem is setting it all up. So for example, you can have an unknown network infrastructure, or you basically you have to have the IP address, you have to connect it to a network, and it gets hard. And I just was thinking of a thing that I thought should have been implemented like a long time ago. So the thing is, those very simple interfaces like we have on some appliances, like you can have a menu, and in the end I made the software system which works with many different kinds of hardware, those kinds of character displays. So you can have buttons, and for example you can have I don't know if you can see it. I'll see what's the quality.
It says networking.
Yeah.
System
So
networking.
yeah, you can have, for example, a wireless menu, and you can see the status. And here it says, "Is it mirrored for you?"
No, it's mirrored for you, but not for us. So it looks.
Nice.
Yeah.
Okay,
software.
so you can see the IP address. You can, for example, connect to some other network. You can even enter your password if it's not there, and it's all by using those buttons. And they didn't stop there, of course. So you basically can do all kinds of things. You can connect. You can write some applications for the system. It's all in Python, and you can easily write some hardware drivers if you need to. I don't know, if you connect your display or buttons through some I/O expander, you can write apps for some sensors for whatever project you have, and it's all very lightweight, and it's all very easy to use.
Can you turn it just a little bit so everyone can see what
Just
is
put
on
it
the
straight
screen?
on.
Yeah, that's better.
Ooh,
Yeah.
multimedia.
Sweet.
Yeah, so you can have, for example, like media player control. So next song, previous song, all kinds of that, volume control.
And what did you program this in? Is it in Python? Is it in C? How did you develop?
It's Python.
Okay, cool.
And
So
Is
yeah.
this, you were telling us yesterday on chat about the wearable version of this. Is that the multimedia?
Well, the wearable version is, it's not really a version of this project. The wearable thing is a Raspberry Pi in an enclosure with batteries, and it uses this interface for everything. So this interface can be used for wearables. I originally developed it for educational purposes, and just for, it helps a lot. But it also proved to be useful in making, for example, a wearable. Even though it's not like a mobile phone interface, it's limited in a way that you only can have one menu at one moment, and you can't really have notifications or something, but I'm working on it.
Cool. And this is a Hackaday IO project as well?
Yep, it's open
Awesome.
source, and you can see the code and install it very easily on GitHub.
Okay, cool. When you post the video, you'll have the link so people can go and make this project themselves.
Yeah.
Awesome. Thank you so much. What a great project and so useful.
Yes.
It's so true. You get a Raspberry Pi. Like, what's the IP address? How do I connect to it?
Mhm.
This should come with every Raspberry Pi.
Yeah.
Yeah,
Yeah.
I wish.
I wish. All right. All right. Thank you so much. Okay, who's next on your list?
Jeremy.
All right, Jeremy, are you here? Yeah, Jeremy.
I am, yes. Can you
Hello.
hear me?
Yeah, you sound
Hi.
great.
Hello. Hi.
Hi.
Yeah, so, well, basically all my projects are about drums. So talk a bit about drum things.
About what?
Drums.
Okay.
Yeah. So I started with, I think you may be able to see if I switch the camera. But started with this thing, which is basically a metronome, was all wire wrap and everything.
Oh, wow.
that's
wow,
cool.
Wow. Wait. Just hold it there so that we can admire
You mean
it.
the bottom, the other side?
Yeah, the
one.
other side. Yeah. That's that.
Ooh.
Ooh, very nice.
And yeah, as you can see, it was really complex.
Sure.
That's just the display part, and I gave up before I did all the audio part. And instead, I just took a Raspberry Pi and I wrote the code in C, and it was easier. But then I improved things, and they released the Raspberry Pi 2 and the touchscreen and everything, and I thought, oh, I'm gonna make my drum module, and yeah, if I just, you can probably see it running right now. So that's the Raspberry Pi 3 with the 7-inch touchscrn. Yeah, and the software is running right now. So that's
Hexadrums.
yeah, that's on Hackaday.io.
Whoa.
That's my project, yeah, Extra Drums, and
Okay.
that's the drum module basically.
Can you drop some beats right now?
I can try. I'm not sure you're gonna hear anything. I've got the headphones nearby.
Oh.
If I start it, I've got the accelerometer here.
Oh.
If you can see anything, but
Yeah, the
it's
accelerometer module.
Yeah, can you see something?
Yeah.
So basically, let me drop the phone. If I tap on it, that's supposed to be on a drum. I don't know if you can hear anything.
Yeah, a little bit.
I hear
bit of
like a
tapping.
snare drum.
Yeah.
Anyway, for the metronome, like I was talking about metronome, it's running right now. You can probably. Hello.
Yeah, it's beeping.
Oh.
That was a good beat.
Oh, okay, you can hear. I think
Oh no, he's gone. That happens. Sometimes people just disappear.
Yeah.
The beat was too intense for him.
Yes.
hello.
Well, you're,
We can hear you, but we can't. Oh, now
I
we can see you.
Yeah.
Okay, good. So I've got I've got the beat. Can configure it, change the like tempo and sound and everything. So if I go to square, changes the sound type. Select different sounds for the drums. All these features, everything you can expect from a drum module, basically. It's still pretty basic, but all those buttons, they're gonna have functions and features, and I can, for example, like make the click faster.
Whoa, so fast.
Yeah, for really fast drummers.
What effects
So, yeah,
can you do?
Sorry?
What sound effects can you do?
Oh no, this is just for drum. If you're a drummer, this helps you with your drums. It's not a drum machine itself.
But it has a button for sound effects.
Oh.
So what does that do?
Oh yeah, that does nothing.
Okay, you were right. You were right. Fine.
It will do cool things like I'm thinking about muffling drums. Some kind of stereo effects, like it's going from right to left and things like that. But so far, nothing's done yet. So it's a work in progress. But yeah, I've got a lot of ideas. I think the main thing will be like this one you can see here is doing
Yeah.
nothing yet, but the rhythm coach is, I think, one of the most important things on a drum kit. I mean, it's helping you. Basically, you've got a metronome. It's telling you if you're going too fast or too slow. It's doing the quiet count thing. So, for example, it stops. The sound stops, but the metronome's still running in the background, and it's checking basically your beat and telling you, oh yeah, you're going too fast, you're going too slow. So it's helping drummers quite a lot. I thought the whole thing is running a touchscreen. I've got 2 LiPo batteries. I can have this thing running for 6 hours. So it's very cool stuff. I've got a lot of ideas for that for the future.
Neat. What a useful tool for
Yeah.
people who drum. They want to have something, and it's easy to control. You can just use a slider.
You drum?
I don't at all.
Oh,
I mean, I
okay.
do kind of like. I don't, but I can tell how this is really useful. Like, you know, people who do music, they're stuck a lot with whatever they can buy in stores. So I always think it's neat when I see people who are musicians and they're like, I'm going to use
Make something
electronics to
special,
make something for myself. All right, awesome. Thank you, Jeremy. That's an awesome project.
Okay.
And also on Hackaday IO. So
Yeah,
wow,
I can
great.
show you
Post all the
quickly
links
the,
up there,
the back of the board. It's just a Raspberry Pi, and you've got a small NCP, well, analog to digital converter. Basically, that's all you need to to make your own drum module. So it's really easy to make.
Very cool.
So cool. All right, we're doing pretty good. So I guess if everyone takes 5 minutes, we'll finish just on time. So this is a good pace.
Yeah.
Good pace.
Perfect.
Okay. Thank you.
Thank you.
Cheers.
Andrew.
All right. So my project is Raspberry Pi Wi-Fi module. Here's kind of the final board. Let's see if my camera will focus.
Ooh, so close.
Upside down. So it's a so the Raspberry Pi Zero came out, and I think a lot of people were complaining that, well, that's great and all, but there's really no connectivity. And I remember seeing somewhere that some of the kernel patches have been kernel changes have been merged in to the Raspberry Pi Linux branch that added SDIO. And I also remember seeing something in a chip teardown that the ESP8266 has SDIO support that isn't really supported. Well, after digging into it, I found out there's a variant of the chip called ESP8089 that's used in a bunch of tablets. There's already a Linux driver for the kernel. And after playing around with it for a while, I figured out, hey, I could, pull some chips off or pull the flash off and use that, because that's where the pins come out, the signals come out for SDIO. And I built this, which was kind of a gross mock-up. I basically ran all the signals from the header into where the flash goes, and actually got it to the driver for these tablets to work. So I kept working on it and wanted to refine it a bit. And I thought, hey, just for me, I'll make a little board. And I actually bought an ESP8266 IC, and this is actually my first RF PCB, and amazingly, it actually worked.
Great, I love that antenna. Such a beautiful antenna.
Well, I stole that from TI. They have
Good.
App
Yes,
note
you
for that,
should.
but
You can app note.
and then people on my project page on Hackaday.io, people start saying, hey, you should find a way to sell these. I would totally buy one. I thought, okay, that's great, except for this is a really hard, really complicated thing to solder, and I couldn't figure out between the cost for the chip and at least ordering it in the US and the components surrounding it, it was more expensive than just buying a module. The problem is that these modules, well, you can't really, actually, this is what I want to show. So these modules have the ESP12F has extra pins that no one really seems to know what they're for. Well, it turns out those are where the flash comes out and the SDIO.
Yeah.
So I figured out a way to bypass the flash without actually opening up the module. I did play with that a bit. And actually just with the soldered down module, connect it with SDIO. So so eventually I ended up with this, and I wanted some fancier things on there. So I added a 2-amp boost converter. So you make things like this, which is the little thing I made for to show off at South by Southwest.
I saw that.
Yeah. Thanks for having me on that one. So it's powered off a 1200 milliamp hour LiPo battery, And see if we can pull it up here. It's actually a LED matrix I pulled off of something, and I've got the board here, and it just stacks, and that's it. So so I thought, this is, my idea was I want to make projects simple where you wanted something small, and you wanted it to be portable, you wanted it to be battery powered, and have Wi-Fi, but you didn't want to have the bulk of a larger Raspberry Pi. So yeah, and it was an interesting process going from, hey, here's an idea, to now I have a Tindy page. So they're still really experimenting in production all the way through, everything all the way through production. It's a lot of work.
Sounds like you learned a lot, though, right?
Yeah, absolutely. It was fun. Yeah, actually, I just got news that the Espressif, the makers of the ESP8266, have agreed to open source their driver. So there are some people helping out with that, and so that's pretty much it.
All right,
Pretty
cool.
awesome.
Do you want to plug your Tindy page?
Yeah, let me open that in another tab here. Sorry.
So we have someone who's got a video card is full error. What is
Video
that?
call is full because we have all the people. There's not enough space for another person.
Oh,
Yeah, if someone drops out, they can
Somebody drops
okay.
out.
Yep.
All right, there we go.
Okay, cool. All right.
Thank you.
Everybody, go support this fine person who has hacked Espressif drivers and kernel modules so that you can add Wi-Fi for. It's cute too. It's so compact and teeny.
Yeah, well, the nice thing is, even though I have it modularized, I have instructions on the Hackaday page to just get an off-the-shelf module, and with just a few resistors, just tack it to the back of your Pi if you're willing to go through that. It's somewhat fine for soldering.
Yeah. You get like a $2 module, pull the flash chip off, and just get the little wires,
Clearly you've done this before.
I have not done that particular hack, but I
haven't done it at all.
No, it's cool. It's a chip that it's interesting. They took a chip that was used for Wi-Fi cards, and then they added this external, it's SPI boot mode.
Mhm.
There's all these pins you have to toggle for the ESP. Well, they don't tell you, but if you don't do that, it turns into a Wi-Fi module.
Huh.
Yeah.
Pretty cool.
Very, very utilitarian, multi-use. Okay, that's awesome. All right, thank you, Andrew. Let's keep going.
Brenda.
Hey, Brenda.
Brenda, can you move up a little bit?
Or your move the video monitor,
Yeah,
camera
we
down.
can only see half of you.
Your glasses are really nice, though.
Yeah, and your audio. Can you
Nice.
hear us?
This is
Yes?
cool. Blink. If you
Wait, no,
could-
she's muted.
Yeah,
She muted herself.
she muted herself, though.
Yeah.
Maybe we'll come back to you if you want to keep hacking on this, Brenda. Okay, now you're unmuted.
Yeah. Let me go. I'm going to just kind of write in here.
Yeah, you can try.
Well, I can barely hear it. Maybe ask her to get closer to her mic.
Brenda, can you come closer to your mic so we can hear you better? All right, we're going to move on to somebody else and then come back to you again right after the next person. Is that okay? Yeah. Oh, wait, now we can hear you. You just have to speak a little louder and hold
You have to
your
speak really
podcast.
loud.
Yeah.
Okay, I'm sorry.
Oh, yeah, now I
it's
can hear
fine.
you.
Yeah, now we hear you.
Yeah, can you hear me now?
Yes.
Yeah, totally. Can you
Okay,
move the
sorry.
monitor down a little bit?
I'm sorry, what can I do for you now?
Can you show us your project?
Oh. Would that be the animal tracker project?
Yep.
Yeah.
That's right.
Okay. I'm sorry, I'm kind of new to this. What should I
That's okay.
do?
This is my first time, so I'm completely new.
Okay. I am very proud to meet you, owner of Adafruit,
Hey.
a website that I go to very often.
Yay.
And I think you reach out to a lot of people older and younger to understand electronics. So do you want to see what I'm doing, or?
Yeah.
Yes.
Show and tell. Show us your tracker project with the sensor tag. I want to check it out.
Okay, so I have done, well, not completed, but basically I have done using a sensor tag from Texas Instruments to predict the latitude and longitude of a moving object without GPS.
Cool.
How'd you do that?
It's not easy, let me tell you. A lot of it has to do with trigonometry and a lot of math that I've had to go back to my days in university when I basically when I had to graduate with a degree in math. So
Can we share your project page?
yes,
Okay. And then what is
I
it
sent
like?
you the link in
Did
there.
you use radios to tell location, or are you using a
Put in project
accelerometer
manager.
sensor? What are you using
Just a
to?
number.
I'm using the Texas Instruments sensor tag, and hopefully I've been able to
No.
with
/
the position of an object with latitude and longitude. And
Oh.
I'm able to project the next position of that object moving with math.
All right. And what animal are you tracking?
Well, my objective, well, I was initially
Nice. So we're showing your project now to everybody.
okay.
And I think there's some,
Are you tracking a fox?
Well, initially it was sort of interested in the fact that a tracker that's put on a fox and PEI is about $40,000.
Whoa.
So can you come up with something that's different that can track an animal without GPS and without the costs that they have to incur?
All right, cool. This will be really handy for especially people who are doing like science
Yeah.
research, and they have to track the moose.
right.
Well,
Or the fox.
Tom Igo, who worked on Arduino, one of his good friends does lion tracking, and she built, Arduinos basically, and they would make these collars to track the lions
That's crazy.
to see where they're going. So sometimes you're like, oh, I have to debug a program. She had to de-lion her program, make sure it was lion safe. All right. Thank you so much, Brenda. That's a cool project. And it's also on Hackaday. Wow. All these projects on Hackaday. Yay! All right, cool. All right. Thanks, Brenda. And we'll post up your project so people can see it in the comments.
Okay.
Thank
Okay,
you.
thank you.
Yay.
Is Dan here?
Dan Aldred.
No?
Dan?
Hey guys, good evening. Hi.
Yes. Yes, I guess so.
Coming through, yeah?
Yes.
Yeah. Okay. So T-Code, you're also known as Dan. That's cool.
Yeah.
All right.
Dan's a better name.
Okay.
Okay.
All right.
Hey.
Well, welcome.
I'll tell you about my project. I made a wearable glove. And the idea is obviously you put it into your fingers. It has some tactile switches here. And it uses Cat5 cable. to connect to the Raspberry Pi via the GPIO ports. And then I wrote a Python code for it, which then triggers some controls. So
can you hold the glove so we can see it?
Yeah,
Screen?
sure.
Just, yeah, without moving it.
Okay.
Okay. Yeah.
So the first button triggers a camera, the Pi camera, so it takes a picture. The second button allows you to then tweet the picture to your Twitter account. The third button runs MP3 music through the Raspberry Pi and the headphone set. And then the fourth one finds the local train times for the local stations in the area. So it scrapes the local. I don't know if you've heard of the National Railway line in the UK. It searches for the details, searches the time, downloads them to a Google spreadsheet doc, and then scrapes it from there and relays them back through your headphones. So that was the original glove.
And what's your use case here? What do you think? Why would somebody want to do all those 4 things at once?
Well, the original idea was that it was for social media. So you're kind of out and about. You don't want to get your phone out your pocket. You don't want to have to, unlock it. So what's easier than just pressing a button on your finger? Oh, I now know what. I've now taken a picture of something. Oh, I now know what time the train's coming. Or I've taken a picture and tweeted it straight away. So the second version is this one. Let me go there. So this one actually has the Raspberry Pi A model actually mounted onto the glove, and the camera is now actually mounted into the actual glove as well. And instead of using tactile switches, I used like the stud presses. So no longer do you actually press it down. You can just touch them together. Joins the circuit. The GPIO pull-up is read in the Python code, and then obviously it reacts. This glove here, though, was created to, I kind of did the social media for the first one, and this one was created to help people around the house. So I used some of the Genie. So I've got a bit of feedback here. Hang on.
Sorry, so the people join and they don't mute their mics. We can hear you. So
right.
this glove is for.
Okay, that's cool. Yeah, this glove here was for like home help. So Genie have made the remote control plugs. So you can control your light switches by pressing the button. The idea would be if you were disabled or you had poor mobility skills, it's probably simple enough for you to put your 2 fingers together, and that would control the light socket. It also, I used a Twilio account, so you can send a text, emoji text to somebody. Again, trying to get your phone out and contact somebody and send a text is very difficult. With this, it's got a predefined text. When you put these 2 fingers together, it triggers the code and sends an emoji text to somebody. I also played around with the optical character recognition, and the idea was that if you were partially sighted, you could then use the camera to take a shot. It would then try and determine or read what the text was saying. It works sometimes, but obviously the original Pi camera was only 5 megapixels, sorry. And I haven't tried it with the new Raspberry Pi 2 camera. But that will be the next project to actually try it with that, and therefore probably get a better quality picture and actually be able to convert the words into text.
And then what would the text be? Sound? Do you go text to text?
Yeah, the text is then converted into speech and just relays it back into your ear. So again, if you're partially sighted and you went towards the door and there was a sign that said, open or pull or whatever, you could take a picture with the camera and it would relay it back into your ear saying to
That's so cool.
That's really cool.
Yeah, I like that
really
idea,
like
because it's like on a Raspberry Pi, it's got,
Yeah.
tools like Festival, like the text-to-speech, it has it all built in.
Yeah.
So you can just take advantage of like decades of Linux development to make usability tools.
Yeah, that's cool. And there's a third version as well, which was made for kids, a Minecraft power glove. So the idea was that there were 4 different kind of Minecraft hacks paired up to each one of the fingers. So you could like build a massive wall of TNT. So if somebody's trying to chase you or get hold of you, suddenly trigger the wall of TNT, or you could flood them out with lava or flood them out with water or jump them into the air and stuff like that. It was quite a cool idea to actually get kids using Minecraft, but also creating a wearable tech glove as well. And then I'm on to the 4th version now, which is going to use the Raspberry Pi Zero, because obviously it's smaller again, and that's going to be a fitness tracker. So probably something to do with music. When you press the buttons, it will randomly select some music, and then some kind of maybe motivational speeches pulled down from Twitter or pulled down from your social media feeds. And then obviously a calorie counter. I'll probably use some kind of accelerometer there to measure how many jumps or motions you've made and build that in as well. So yeah, that's where we are now.
That's cool. It's interesting. You have 3 gloves but only 2 hands, so you have to start making Raspberry Pi socks.
Definitely.
That glove's got a lot going on.
And that's
it's a
cool.
Pretty cool project.
And I know that with the Hackaday prize that you run, there's accessibility sub-projects in it. So that's kind of neat. So neat to see people taking this technology and thinking of others.
The idea would, like I said, the idea would be that you buy the glove and then you download the code for the glove. So the glove is standard with the camera and with accelerometer and Wi-Fi access, etc. But then you download the code, and if you want the social media one, then download it onto your memory card and off you go. Or if you want the home accessibility, download it. Or if you want the sports one, so you've got one glove, but lots of different uses for it.
I dig it. That's cool.
Thank you.
I can tell you're like, I'm on the glove path. All right. Okay, so we're halfway through.
We are.
Is this working out? Is this, this is 30 minutes. Is this great?
This is pretty good.
Okay, I'm glad this is working out. Because that would be sad if you're like, we should just quit now. But no, we're not. We're going to do another 30
definitely
minutes.
Not quitting right now.
No.
Because you know what? Chiptunes is up next.
No way.
Chiptunes.
All right.
Jarek.
Yeah. All right, let's, you gotta.
Yeah, we didn't get to do any tests with you. Sorry.
Hello? Jarek was here, but now Jarek, he looks like he's a chip. He's like kind of like pixelated. Oh, hey.
Hello?
Hello.
Hi.
Thanks for finally got into the room. Looking forward to show off my Raspberry Pi project. It's called Chiptune Forever. You get my camera on the Pi really quick. So here's a circuit board that I made, which takes the sound chips from a Sega Genesis, and it connects them on a Pi hat to a Raspberry Pi. Raspberry Pi only operates at 3.3 volts. These old chips, they're all the way up at 5 volts. So I used a couple of 595s to do the level translation, and also it's just easier to use the SPI bus to talk to an 8-bit data bus and the latches that are on these chips. So I'm just going to play a little demo of how the chiptune project sounds right now. So right now, all these sounds that you're going to hear are being synthesized by the chips. It's not any onboard software synthesis. This is the actual sound data coming from the chips. So, so if you're a fan of Sonic the Hedgehog, you may have noticed that was the end credits sequence. It's still a little bit funky because I'm having a hard time. This is my first time actually programming something in Linux. I'm going to take out the sound chip and put it in an older board I made it to give you a reference of what it's supposed to sound like. I'm way better at doing AVR and ARM stuff than I am doing Linux stuff. So at the end, I will ask a question to the audience that I hope I can get some guidance on. But again, just for reference, here's what that track was supposed to sound like. Put this in. So this is a board I custom designed using an Adafruit Feather actually to prototype.
Nice.
Let me plug the SD card in, reset the board. So you can probably hear that is way more on beat and on time and everything.
And do you pull those chips from a Sega?
Sorry about that. Yes? I didn't hear the question.
Oh.
It's a little loud.
Oh, do you pull the chips from a Sega?
Thankfully, there are still enough aftermarket parts for Sega arcade hardware that I don't have to do the pulls myself, so I'm not tearing apart Segas to do it. But you can easily find these chips on eBay for like a couple bucks each.
Nice.
So I did put the source code and schematics for the hat on the IO page, and I'm really hoping I can get some traction on this because, again, I'm a total novice when it comes to Linux C programming, and implementing the delay function that I did using an ARM was way easier because, of course, I'm not fighting with the OS for resources or hacking microsecond delay loops into it. It's like something a microcontroller is just better at. But while I was developing the microcontroller-based solution, the amount of time it took just to get one sound chip working was a really, really big impediment to what my plan is to, eventually I want to create a common platform for all the chiptune instruments of the past. I'm really big into chiptune. I started with the Chip Maestro way back when, doing NES chiptune emulation, synthesis. And I just wanted to see if I can find something that the rest of the community can latch onto, just sort of a backbone for all the rest of the chiptune instruments that are out there. If you try to, like, for example, do a search for the Pokey or the AY 3980 or 3810 chip, which is also very popular, pretty much everyone has to start from scratch. No one's ever taken it all the way, or no one's ever fully published everything they've done. So I'm hoping with a good I/O page, a lot of exposure, maybe I can get some people who are also interested in chiptune on board, helping each other out.
Cool. I hope so too.
Okay, so if anyone's watching and they're really into timer interrupts on Raspberry Pi Linux, so they know how to get stuff working. It sounds like you need to have a really precise timing. This is a good, so check out the Hackaday IO project page for the chiptune. We'll be in the comments also. Yeah. And there's a forum, right? People can post comments.
Yep.
Just post a comment and be like, hey, I happen to be a fan of chiptune and real-time operating systems. And maybe it'll help them out. This could be a glorious new future.
You can also join my team. I'm really looking forward to working with a lot more people in the community. I know it's kind of hard. They're mostly concentrated on forums like nestdev.org or vgmrips.net, but maybe pulling everyone together into hackaday.io will get the groundswell going, get all our favorite instruments back online.
That's a glorious vision.
All right, cool. So that was a nice musical interlude.
Yes.
Who's next?
Michael.
All right, Michael.
Stop.
Yeah. Hey, Michael.
Hi, can you hear me?
Yeah, you sound great.
Great, thank you. So I'm going to show you some really low resolution projectors. I have some of the projection happening behind me right now. The idea really started when I saw some amazing projects done with flip dots, like from old train stations. And I saw a beautiful piece that was done by a design studio that looked kind of like a cloud that was covered with flip dots that were mirrors on one side and black on the other.
That is the best project. I totally
I haven't seen that project. That sounds amazing.
Thank you.
It's called
Does it go click, 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 click?
It does.
Ah.
It's in
yeah.
airport in
Okay.
London.
You gotta fly to London.
Yeah.
Okay, sorry. Keep going.
So yeah, so I saw those mirrors and thought, well, maybe I could make some sort of optical device using the mirrors, kind of misusing them to reflect light. And so I ended up developing this series of networked low-resolution projectors that use a 7x7 pixel grid in each of the devices. And I really wanted them to be wireless so that I could set them up in any orientation. I have two set up in a corner here behind me. They could be set up next to each other along a really long wall, or they could be set up really long distances away from each other. So I didn't want to build one device with many of these tiles, but to have them kind of deployable all around the place. So I ended up getting some of the devices from Alpha Zeta, which is like the premier company for such devices. You can see the back of it there with their logo. I believe it came from Poland, and I had to wait quite a while to get that. But this is the complete device. It's got a Raspberry Pi in the corner, an RS-486 chip on top to do the translation in the format that the pixels want to receive that. And then I hacked off part of a flashlight. And so this acrylic box holds all of the guts and lets you kind of see how it operates as it's doing its display. And right now I have some abstract graphics running behind me, as well as streaming text information that it can display as well.
It's beautiful.
Cool. Yeah.
Thank you.
So I have a question for the flip dots you got. Did you have to apply a mirror finish to them, or are they mirrored already?
So they're available usually with white on one side and black on the other. You can get colors like the fluorescent green you may have seen on road construction signs. But one of the options that this company offers comes with silver mylar.
Okay.
So it's not a first surface mirror, which would be ideal, but with a bright enough LED and not caring too much about the quality, it reflects a lot of light off of there and stays with a pretty nice beam.
Okay, cool.
That's a really unique use for the flip dots too.
You know what? 7x7 is more than enough for anything. I mean, what?
Yeah.
That's 49 full dots.
Yeah.
Yeah.
But it's only like this big.
I know, but they're so cute. And they go click, 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 click.
Yeah.
All right, that's an awesome project.
Thank you. I ended up programming the whole thing in processing. I got into programming through some microcontrollers a while ago, and then kind of graduated to Arduino, and then got into processing through that.
Mm-hmm.
And so it's really kind of my weapon of choice for most things. Graphical wasn't really a natural fit for the Raspberry Pi, but eventually, it's pretty well supported processing on the Raspberry.
Mm-hmm.
And with was working going. That was probably the biggest stumbling block, and some of the things on my Hackaday IO page talk about frustrations with the system not being able to read its own IP address and causing some problems. But it was really nice to be able to write code on a Mac, on Windows, and then be able to just run the exact same code on the Raspberry Pi once I had it kind of worked out.
Cool. Yeah, you've got Internet of Flip Dots going on. You can talk to Arceus and you can make a little, you can have his shield added on top.
Yep. And then you'll know always what the IP address is.
know.
And all those other useful things.
All right.
Yeah, that looks like an awesome project. Thanks.
So we had sound and we had lights.
Yeah, I know. This is like art
multimedia.
Yeah.
Okay, cool.
Nick Sayre.
Hello.
Hi, Nick.
Hello.
Okay, we can hear you.
Hello. My project, let me flip my camera around so I can see here. My project is...
Can you speak up just a little bit?
I have to apologize. My project is a little bit simple. So you can see this is a Pi Zero and this nice Adafruit case for it that I like so much. The thing on top is just a power supply that's called Pi Power. A GPS timing module breakout board. It's very similar to the one you can get from Adafruit. The difference is that this is a navigational module, and this is a timing module. What the module does is it will, after it starts up, it'll take a survey of its position. And once it has the survey, then it can get very good timing solutions with only even a single satellite, requiring like 4 satellites to get a 3D fix, and then being able to derive timing information from that. So it's just a slightly different set of assumptions in the algorithm for how that works. So I'm not the first to make a Raspberry Pi NTP server. So this is just a network time server. The whole idea is it serves time of day information as part of the NTP pool. Port for it. I got this from Adafruit as well. This is a USB and Ethernet combo thing specifically for Raspberry Pis. And that's all there is really visually to it. Just a couple of blinky lights is kind of over here. I hope you can see the screen, kinda.
Yeah.
Yeah, it's actually pretty good contrast.
Yeah.
I'll run this again. This is the output from NTP, the NTP daemon on there. And so most of the stuff from here down is just backup servers that are on the internet that are configured to it. It's using the NTP pool. This SHM line here, that's from the NMEA time sentences that you get from the GPS receiver. And then the top one is the PPS. That's the pulse per second. And that's what really synchronizes things. And right now, this is within 92 microseconds of GPS time. time on this machine. And you can also back that up if you watch output itself. Timestamps of the PPS pulses coming from the GPS receiver are, well, call it closer to 100 microns away from the local time, but that's pretty good, I would say. If you're running NTP on the internet generally, you're going to get maybe within a millisecond or so. This is another order of magnitude better than that. This is the status page for that particular Pi 0 NTP server within the NTP pool itself. And it's the green scatter plot that's kind of down there shows that it really stays within about, well, you can't see the scale, unfortunately, but historically it's about 3 milliseconds off at the Los Angeles monitoring point that the the NTP pool uses to track this sort of stuff. I don't know what happened in here, but maybe the monitoring site, I'm not sure. That's about it. So I am not by any means the first to do a Raspberry Pi NTP server. The project page that I created, I sort of coalesced all of the steps that I took to get there with the most recent distribution and kind of made it as much a cookie cutter as I could. And that's what I've got to share.
Awesome. Well, very timely, as it were.
Yeah.
Oh, thanks,
very
Nick.
precise. All right, awesome. Okay, so we got the time, we got music, we got sound. Who's next?
Kyle.
Kyle, you're up.
Can you hear me?
Yeah, you sound great.
Hi, thanks for having me. So I developed a software project called my Coda, and I originally developed it because I had a need to grow gourmet mushrooms. And if you're not familiar with the process, you have to regulate certain environmental conditions precisely throughout the growth stages, and they have to change. And there wasn't an easy way that I could do this other than doing it manually. So I originally started this with an 18 mega connected to my Linux computer, and that was networked to a web server. And then when the Raspberry Pi was developed in 2012, I sort of started tinkering with that. And let me pan over here. So right now I have a grow tent, and this is the actual project box that I have it inside with a touch screen. There's the Raspberry Pi, and right now I have 2 40 amp relays, 4 10 amp relays, and 4 2 amp relays, and I have about 9 devices connected with these wall sockets at the bottom right now. But essentially what this does, it allows you to use PID control, which has been used throughout industry to control environmental regulations for a really long time, but it allows you to use it now with your Raspberry Pi. So for instance, right now I have down here, I have a pot of water that's being circulated and heated to about 57 degrees, and I have a steak and a burger being cooked. And I also have in my tent here humidity being regulated, as well as a light cycle and a water cycle to grow herbs for that. So it essentially allows you to do all this through a web interface that I built with the Flask micro framework, and then a daemon for the backend that controls sensor measurements, adding to the database, and being able to pull those to be able to get the output that it needs to turn on and off these devices. So essentially you couple a sensor input that monitors an environmental condition, and you then couple it with a relay with a device that can modulate that environmental condition. And using the PID control, it can modulate that relay output, putting power or energy into the system that you have, changing that environmental condition. So you can regulate it steadily. You can change it over time to different set points that you want. So for instance, if there's a guy in Romania that's fermenting and aging tobacco, he has a 3-month regimen that changes every few days to a different temperature and a different humidity. Same thing happens with mushroom growing. So you have the colonization, which needs a certain humidity and temperature. You then have the primordia formation that's eventually going to turn into the fruiting body or mushrooms that needs a certain amount of light, CO2 concentration, temperature, and humidity. And then you need to have a very high humidity and a higher temperature for the fruiting body growth, which will give you your mushrooms. So this allows you to do all that, and you don't even need to be home. You can have it hooked up to the internet, and you can look at it on your phone. I was actually in California for the past 2 weeks, while I was having my herbs being grown. So I was able to monitor them. I have webcam access. I did a 3-week time lapse. Let me see if I can show you inside the tent here.
Just about to ask.
I was like,
Can
let's
we
go in the tent.
Oh,
that's
that's
neat.
super cool.
All right, yellow pump there. All right.
Pretty nice.
This is cool. You're like you're like
Yeah.
the Martian, but you're here. You're ready to colonize Mars.
Great analogy.
No, this is it's
so
what we
true, though,
study.
yeah.
We're like, how do we
Yeah.
grow things? And also, like, agriculture is such a huge
Mm-hmm.
like growth environment for engineers.
Yeah.
You know, I love to
Absolutely.
see how engineers are just like, I want to grow tomatoes in the most efficient way possible, you know, and they go crazy. So this is cool. I love this
Yeah.
project. I'm going to check this out. So it's my Coda.
Yeah,
Yeah.
so I initially started for mushroom growing, but people have been using it for all different purposes. I work with a guy just testing on one of his pies, but he uses it for incubating snake eggs, corn snakes that he has this project he's starting with his kids, and it's now growing because he now has this. Is
Okay.
people that are fermenting tempeh, sauerkraut, beer, wine.
Yogurt, I know yogurt
aging-
people, they freak
Yeah.
out. They got to have the exact right temperature.
Totally.
Yeah, so there's a lot of
And
uses for it. Yeah.
And this project's also a Hackaday Prize finalist.
Yep, and the
All right.
automation.
Yeah.
Okay, I'm not a judge, so I can say this is a cool project, and I hope you win. And
Thanks.
it's awesome. Yeah, this
Yeah.
is such a common request for people. They want
Yeah.
such a full system.
You can eat the results.
Yeah, you can.
Yeah.
You should send Sophie, like, you know,
Some
mushrooms
mushrooms, yeah.
and like some herbs that she can eat. You can bribe the judges.
Sure, yeah.
Yeah. Right.
Delicious food. All right, this is cool. What a great,
All right.
useful
Oh,
project.
now we have one more person, I think.
Okay.
If Elliot is here.
And if,
Elliot?
John, did we get to John?
Do we get to everybody? John? No.
Your special guest.
No, actually I just don't have him on the list.
Okay.
Can you hear me?
Yeah.
Okay, well, why don't you present your project?
Can you hear me?
Yeah, we can hear you.
It's a bit of a delay. So this is the Nintendo TV, which is a retro console, completely self-contained. There's USB ports on the front to plug in modern versions of retro controllers. A Raspberry Pi 3 inside, so it has Bluetooth. So PlayStation 3 and 4 controllers, I think, work, and I think the newest Xbox controllers work as well. Back, I have little Velcro things that hold on to the controllers. So let me get those off of there. Power cord just kind of gets over here, and that way it's just really easy to carry, and you're not worrying about things falling around. And it has these nice little handles in the side that you can grab on and walk around with. And then I added on the back here is an HDMI port that's connected to the Raspberry Pi internally. So if you don't want to use the games, you can plug it into a modern TV or LCD or whatever and play it that way. So there's actually a separate power button for the Raspberry Pi, on and off independently of the CRT itself. So let me put this back around and plug it in. I reach behind and press the Pi, and then I will turn the TV on. So it may screw up the camera. I'm not sure exactly what's going to happen, but we'll see.
Nobody knows what's going to happen.
To the internal input, and it'll boot.
Yes.
Kind of
Yay!
hard to see, but we've got a splash screen on it. So I just have the Super Nintendo USB controllers. They just plug directly into the front. Times up all the way. And just do whatever I want on here. I usually do the ending just because it's my favorite. I have on here, but we'll just pick one. Here. Let's see what that is. And then there we go.
Cool.
Oh, that's nostalgic.
It's just got the Raspberry Pi in it, so it does have Wi-Fi internally, which is super nice. It let me bring all 4 of the USB ports to the front without having to dedicate one of them to a USB or a Bluetooth dongle. Nice, and then other just kind of pain.
And I have a question. Is that a TV that you modified? I can't quite tell. Is it a TV you modified, or did you build that enclosure from scratch with a TFT display?
The TV was originally a DVD TV combo unit. So where the USB ports are, is actually where the slot for the DVD drive used to be.
Oh.
So I actually chose this TV because of the fact that it had a DVD drive in it, guaranteeing space inside Raspberry Pi in its entirety. So I just ripped the DVD drive out, pulled everything out that wasn't necessary, that was just in the way. And so the Raspberry Pi is in case I isolated it from the TV, but it's just kind of underneath the seat in the area the DVD drive used to be. And then the HDMI on the back is just like a 1-foot HDMI extension that had brackets mounted to.
I totally had one of those VHS taped TVs when I was in college.
Oh, nice.
You know what I'm talking about?
Yeah,
the all-in
totally.
ones. They're like $99.
Yeah.
Yeah.
I didn't have a TV in college.
Oh.
The Raspberry Pi actually connected internally to the. They're on the side. So if the TV is off, you can actually use these RCA jacks as an output if you wanted to do composite out. Or you can use and then the headphone jack here actually still works even when you're doing it on here.
Cool.
Cool. Yeah.
All right. Yeah. That was great. And we got to everybody, plus some.
Yeah, totally.
Okay. Thank you, everybody.
Thanks for coming, everyone. We'll post all the links to all your projects in the comments.
That's so awesome. What a great, this is your first
Show and tell.
Show and tell hangout.
Yeah.
Well, what is the actual official name of this? Is it
Hackaday TV.
Hackaday TV.
Yeah.
Wow, you have a new, this is your
new
first
name.
show, a new name. Do you have to do like multiple shows too?
We might do another show.
Are you gonna do another one of these?
Yeah.
You think so?
Yeah.
It worked out?
It worked out.
Okay.
Thanks.
It's a partnership of chaos. Thank you. All right, everybody. Well, I guess you'll blog it up next time you do one.
Yeah.
All right, so get your projects ready, your Nintendos and your Flip Dots, and we'll check you out next time. Say goodbye to Sophie. She put this thing together. Thank
Bye,
you,
Sophie.
Thank you, Sophie.
Thank you.